to the resonance phenomenon. Yesterday, when I was uh, taking class, or when I was explaining the resonance phenomenon, I told you that resonance is something which is happening because of the uh, coordination between two variations. That is what I was telling you. So let me explain it again. When there are two variations in a circuit or a place, when the two variations match, what happens? There is going to be a big change happening, right? So let me explain it again. Now, in a series resistor, inductor, and capacitance circuit is there, and you are supplying it with a voltage source. Okay, so when you are supplying this with a voltage source, what will happen? The inductor and sorry, the sorry, 1 minute. The inductor and capacitor, they are energy storage devices. Okay, so inductor, as I have told you, it is a flux storing device. Capacitor is charge storing device. So in inductor, once the current is flowing, the generated flux will the flux will be induced, and the properties of the inductor is based on the equation V is equals to L di by dt. So we can write this as XL into I. Right. So this XL is the impedance offered by the reactor. Similarly, when we talk about capacitor, the impedance offered by the capacitor is XC into I. So the this is the voltage developed across the inductor and the capacitor. So once the current is flowing through these elements, the voltage drops across inductor and capacitors is going to be XL into I and XC into I. And you can you can notice this as V is equal to J omega L into I, whereas VL, VC is minus J omega C into I. Okay. So what you can notice this is the here there is a voltage drop and here there is a voltage rise. So at one particular frequency, what happens? The voltage drop here and voltage rise here will get cancelled, and your current through the circuit becomes maximum. So this here what we are doing, we are varying the energy storage capacities of inductor and capacitance, and we are matching it at one particular frequency, making the current maximum possible through the circuit. So this is achieved using this resonance phenomenon, and this is where this resonance is used. There are various applications where this phenomenon is applied to achieve the required amount of current through the circuit. Okay, so this is the equation part of resonance, what's happening. Now let me tell some details about the graph that I have drawn. So here in this graph, you can notice that there is a frequency at which the current is high, and when in a parallel circuit, there is a frequency where the current is low. So this frequency is called resonant frequency for series, and this is resonant frequency for parallel. Other than this, there are certain parameters on which you will be asked questions in your examination. That's called quality factor and bandwidth. Okay, so you should understand what's this about. These parameters are nothing but it gives the these are indices or properties of the resonance circuit based on which they'll choose the resonance circuit for the particular applications. That is the role of the quality factor and bandwidth. So quality factor is nothing but the power or the energy stored divided by the energy dissipated. Okay. So, energy stored, energy dissipated. What is this? If you can think relating to the circuit RLC or series or parallel RLC, whatever the circuit might be. Here we have elements, energy storing devices, and energy dissipating devices. The actual purpose of the resonance circuit is to match these inductance and capacitance properties and get the maximum the current through the resistor. So when you flow maximum current or maximum voltage across the resistor, the power dissipation in the resistance has to be minimum, right? So that's the quality of the resonance circuit. If the power dissipation in the resistor is higher, then your quality is low. That's the purpose of quality factor. So that's why the formula is power or energy stored divided by the energy dissipated in your resistance. So then coming to the bandwidth, bandwidth is the range of frequencies in which your current is 1 by root 2 times. Okay, so why 1 by root 2 times? Between this frequency, you have maximum amplitude of your current. So that's why they have chosen this bandwidth, the range of frequency at which your current reaches its maximum, or the range of frequencies where the current reaches its minimum in the case of your parallel circuit. So this is what I thought of telling you guys, because whatever the problem that has been asked in your question paper from your resonance, there cannot be question out of this topic. They'll usually ask the resonant frequency, quality factor, bandwidth. Based on the formulae, you will have the questions, which is direct application of your formula. So you can just solve, I mean, remember the problems coming under resonant frequency using the formula.